This is a Carboline production.
Controlling soluble salts is one of the largest challenges faced during the surface preparation portion of a coating project. Failure to remove soluble salts can drastically shorten a coating's life cycle. On this episode, Kon Rossy, president of HoldTight, joins us to discuss the differences between atmospheric and immersion services, the debate on allowable soluble salt limits, and how additives can help. All of this and more next on The Red Bucket.
Hey, Paul, how's it going, man? We're back in Houston again, and we have to talk about something important that happened today. It was very important.
I know what I would talk about, but what do you think was important today?
Breakfast.
Oh, yeah. We will be going back there tomorrow.
Yeah, so we went to this place that was a biscuit place, but you ended up getting some kind of waffle, chicken, egg, honey, butter, gravy awesomeness. And I had basically the same thing, but with a biscuit.
Yeah. I wanted yours, although my waffle was fantastic. The whole time I'm thinking going, oh, but that biscuit, that looks really good that way too.
It was really good. So if you're in Houston, I'll give a shout out to the Flying Biscuit. You want to go there? It's really good.
Yeah.
So anyway, we have a longtime friend of the show that's back on, and his name is Kon Rossy. He's the president of HoldTight Solutions. Ken, welcome back to the show.
Thanks. Looking forward to being here.
So why don't you tell us a little bit about yourself, how you got into the industry, how you came to HoldTight?
Yeah, my background with coatings goes back to the early 90s. And my dad actually had a manufacturer's rep agency here in the Houston area. And he invited my brother and I to join him as his territory grew. And at the time he was selling Plasite and additional companies. And so, you know, I gave up my commercial real estate degree and decided that, you know, the family business was much more important. And so, yeah, I started in 91. And started calling on plants selling coatings and sold coatings, well, until I came to HoldTight. With HoldTight, you know, I'd always known that surface prep was really important. Being a good coating salesman, that surface preparation, I always had somebody else. Yeah. Always had somebody else to blame a failure on. But now I'm on the other side as far as that little equation goes. And, you know, surface prep just was, you know, I had the words, but I didn't really understand what it meant. And so with HoldTight, it's given me a much more balanced view of a coating system and what it takes to be successful and what you want in a good coating system.
Yeah. So why don't you tell us a little bit about HoldTight? Where did it come from? How did it come to be? Sure. And what do you guys do now?
Yeah. Well, HoldTight, we began basically about 35 years ago. And I say basically because it was born out of another adventure that the founder had. He originally came to Houston after he quit working for the Jimmy Carter administration. Okay. And he grew up here in Houston, wanted to create a company, a business here. And so he started a steel fabrication plant. And in the process, he realized that that's not as lucrative as he had hoped it to be. So he started developing other products and other ways to broaden his revenue stream. And he actually was one of the early persons to bring to market water jetting, a piece of equipment using water to clean a surface, high pressure.
And there's consequences to putting water on steel.
There is. So once he realized that those consequences were not acceptable to all the people that might use his equipment, he had to come up with a way to prevent that consequence, which is basically flash rusting. And so he had a chemist, and they developed probably half a dozen different versions and landed on 102. So it was 101 through 106 or 104 or something like that. And 102 is the one that stuck. So, he just really shut down the steel fabrication business, shut down the equipment side of it because the market wasn't quite ready for that yet. and began to really promote and evangelize the concept of removing salts and the need to do that to improve coating systems. So I give him all the credit for us being here.
Yeah, that's a great history of really a ground roots, way up through the network that says, no, here's a problem. I mean, that's not dissimilar to Carboline's background of
exactly.
Here's a problem and we need to find a solution and how we're going to work through that. So those are the ones that usually stick around.
Yeah, and it was it was something that the market wasn't really there for that level of that requirement as far as removing salts and cleaning the steel. But quite honestly, what really promoted it was when the equipment manufacturing caught up with them. When wet abrasive blasting equipment began to get its foothold in the market. Mm-hmm. And people, especially here in the Texas Gulf Coast, in all the plants, you have to suppress dust. Yeah. And so the best way to do that is with water, or what used to be, and they still use them, the water shield, which would be over a typical blast nozzle, but a shield of water that would flow out and suppress the dust that way. Any way to get water on the surface to not only suppress, but then as people discovered, to clean better. Yeah. Clean steel makes for a better coating system.
Yep.
So let's talk about that for a minute, because, you brought up salts, and it's something that I don't think everybody thinks about, that, there's salts in the air. There could be salts from chemical fallout. There could be salts or chlorides from being close to the ocean. But why are those detrimental to steel?
Yeah, well, it's real. It's very basic as far as just going back to your high school chemistry, in that salts, when they're left on a surface and a coating is put over them, they are somewhat like little magnets, and they will attract water, and most coating systems are permeable. So water will travel through that coating system. And if there's water there, then it's going to immediately attract, and it will continue to attract, and which will lead then to what we call osmotic blistering. Mm-hmm. So typical failure of coating systems when it has to do with salts are osmotic blistering. And as we all know, selling tank linings, as I did in the early part of my career, some people would live with those blisters and other people would not, depending on what they were trying to get out of a particular lining system or the life that it had left on it. And so, it's always just felt like that was just a part of a coating system. And that's what you just did. You just waited for those blisters to appear. But it doesn't have to be that way. And I think that's what, over the last 15 to 20 years, our industry has determined, that a cleaner piece of steel is going to be much better for a coating system than one that has these unseen, invisible salts on the surface. So it just becomes a cathode and an anode reaction with water, the salt, the steel, and you create that pathway.
Yeah, and I think a really key thing that you just mentioned, invisible contaminants. Mm-hmm. Because when we talk about standard surface prep, all of the NACE and SSPC standards, you start with an SP1, which is the removal of visible contaminants. Mm-hmm. Those standards do not address salts. And the typical salts, Jack had mentioned, chlorides, sulfates, and nitrates. Those are the ones that we're normally at. But when they're in their dry form, you typically don't see them on the surface.
Right.
And so that's microscopic or transparent to some degree. And when you paint over them, the degree of a blister, or whether or not you can allow it to stay, is going to be frequently dependent on the amount of free moisture in the chemical that's in the lining.
Right.
So if you have something that, let's say it's crude oil and there's very little to no moisture in it, those blisters aren't as hazardous.
Right.
There's no moisture to be going through. But if you're working with a water tank, water is now all pretty prevalent.
Right.
And it does cause a bigger problem. And that's really, I think, what has come down to, do we have to deal with it and how?
Right. But what we've also come to find out now as we become more understanding of what salts can do to a coating system, they now, if you look at a piece of steel that's clean, especially to the naked eye, and you've achieved your cleanliness standard that's required, it all looks good just naked eye and at 10 to 15 times magnification. But when you up that magnification to about 500 times, you start seeing these little rocks on there. You see these little fractured, these little rust worms that you don't see with the naked eye, but they're there. And those are the little things that not only with the salts that create the blisters, but if you've got fractured blast media on there, and especially if it's allowed to gather in a particular area, then you're not getting full contact of that coating system to the steel. Right. And that should be the goal of any good coating system, whether it's atmospheric or immersion, that you have full contact. And that means not only the surface of it, but also down into the profile.
That's right, because we're creating that profile to give us a bigger surface area for a coating to stick to. I mean, it's always funny when somebody sends in a paint, say, your paint fell off, they send it in and the back of it's covered with dirt. And you look at them and you go, nope, my paint stuck perfectly. It did exactly what it was supposed to do. Like, what do you mean it's coming off on sheets? And I said, it stuck to every piece of dirt that you left on that tank. Right. Your dirt fell off.
Right.
The paint stuck great. Right. The dirt fell off.
Right.
Well, before we talk about the dirt, I think a thing that was important to talk about is we talked about invisible.
Yeah.
Right.
So, Ken, how do we find these salts?
Well, that's a great question. And there has been, over the last 20, 25 years, we've become much more sophisticated with being able to test surfaces and to be able to come up with a reading that tells you how many microsiemens per square centimeter is on the surface. So it's not difficult to determine. We can even fine tune it to the type of salts that are on the surface. Yep. There's a lot of people feel like if it's a chloride, it's a chloride. So it doesn't really matter what it is, but there are a lot of specifications written around, as you mentioned, CSN. And so knowing what that is very important. And it's all driven by the specification. Mm-hmm. If a specification doesn't call for anything, contractors are not going to bid it.
No.
But if it does, and then if it calls for a specific type of test, then that all has to be followed. And so that would be, conductivity is really what you're trying to find, because not only is conductivity going to read the salts, but it's also going to read other, conductive ions that are on that surface that could, not always, but could impact the coating system.
And a conductivity test is generic enough that it just gives you all of them. And it's whatever is causing there to be essentially a current through the liquid.
Right.
And so that way you're not, well, here's one that we didn't know was there, and
right.
It ends up, giving us an errant reading.
Exactly.
But, yeah.
So pro tip, engineers out there, you're writing a specification, include something about soluble salts.
Right.
Yeah.
Exactly. Yeah. And what we confuse, I think, also is cleanliness. In the industry, traditionally, cleanliness had to do with the amount of profile and how much of the surface was cleaned of existing rust. But cleanliness now, with the advent of understanding what salts can do to a coating system, cleanliness has a double meaning almost, in that it's your surface profile, it's your surface blast, but it's also physically the cleanliness of that steel. Is there anything left on there that's going to impact adhesion? I remember back in the day, every spec just called for, or every contractor would sweep down an area with a broom, blow it down maybe with a outdoor residential blower, and they might have clean air, maybe or maybe not, and that was cleanliness.
Yeah.
Mm-hmm.
That's all you had to do. But as we become more sophisticated and as owners have demanded a longer life from their coating systems that they're spending a lot of money for, then why not really understand what's on that surface?
And, I would argue one of the things that's also changed is, and it comes up a lot, the environmental impact of what we've done, where we used to use linings, especially, that were 30 and 40% solids, which means you have a lot of liquid on the surface to displace things, which meant if you had a stray piece of blast media or something, the coating itself was much more forgiving. As we have improved the environmentalness in the coatings, this is one of the side effects. We now need cleaner substrates to put that paint on.
Yeah, because really what has happened is that many coating systems that used to be a very thick film coating, especially in the immersion world, have gotten thinner.
Yeah.
And especially as you're going to, low VOC or no VOC coating systems, it's just caused that to reduce that thickness of the film, which is great, but it makes it even more important that you're applying it to a clean surface.
Yeah. So we've kind of tiptoed around it, and we've talked a lot about how salts and cleanliness is so important with immersion service, but it is also for atmospheric exposures. You want to talk a little bit about some of the difficulties or nuances, what we see, comparing the two?
Yeah, it's, because atmospheric is really going to be much more susceptible, in my mind, to salts because you've got environmental impact on a surface. You've got, if you're along the, say the Texas Gulf Coast, you've got just the marine activity, in the air that's going to create salts or deposit salts on the surface. But then you've also, with all these plants, all the refineries, you've got salts that are chemically being created that then are left on the surface. And all that typically occurs on the outside of a tank, outside of steel, of piping.
Bridges and pipes.
Bridges. Yep. And that's where, many times that can be just as important, if not more important than an immersion. Because with immersion, it still is very important, but you are typically, your surface preparation procedures are a little bit more robust with the amount of blasting done. And many times can even be done with like UHP or ultra high pressure, water jetting. And, that's going to naturally remove a lot of salts, but it's still important, no matter whether it's immersion or atmospheric, that what's on the surface, and that's documented. And I think that's where the engineering world, the owners have all demanded and are finding that they can cover themselves by running those tests and knowing what they are going over. And it's just, like I said initially, as a coating salesman, it was always nice to be able to blame surface preparation. But, that argument or that opportunity is being reduced as everybody understands what can happen with the surface that's not really clean.
Yeah. So one of the things that we see as we talked about, the available water influences the osmotic blister, and that's one of the benefits we have with atmospheric coatings is there's less water available than there is inside a tank. But the problem is there's more salts presented to it. And like you said, Ken, the tank painters typically are not also bridge painters. Those are very different skill sets.
Usually.
So in those cases, their surface prep, their ideas, you look at how many times is a bridge overcoated. We don't ever overcoat the inside of a tank lining, but you overcoat bridges all the time. So that understanding those processes are very different for something that's done out in the atmosphere.
Right.
Not to mention containment is much harder on a bridge than it is in a tank.
Right.
The tank is meant to hold everything inside it. So everything settles on the bottom and you clean it up. But, you'll bridge over a highway or over a body of water. That's a much different monster to tame as to how to contain that.
It's interesting though, if we had the ability to run an average of length of life of a coating system on a bridge versus a tank, exterior of a tank versus the interior of a tank, piping or whatever, if we had that data available to us, my guess is that we would now see a longer life coming out of those coating systems simply because we're talking about bridges. Cleaning steel and removing salt, as the DOTs in various states have approved it, has become much more important to a coating system. And I would just have to guess that the life of coating systems is incrementally increasing as we improve. And it's just not removal of salts. There's a lot of things that our industry, even though we're a very mature industry, we still have a lot of things, new technology, new ways of doing things that have come out that make us exciting and relevant.
In the industry, there's great debate over the amount of allowable soluble salts. Because here's the thing. You can wash that tank 100 million times.
Yep.
You're not getting everything off.
You're a numbers guy, aren't you?
Whatever.
You're also a pessimist.
A little bit, yeah, because you're not going to get it all off. You're just not. So let's talk about not necessarily the debate, but the why is there a debate between the amount that you're allowed to leave on the surface? Because one would think, we have all these committees. We can just get together with a committee, hash it out, and put it down, right? But we can't.
Right.
Ken and I have sat in some of those same meetings. There's a lot of hashing, but none of it's out.
Yeah.
Right. So why?
Well, to be honest with you, we always push it back on y'all as the coating manufacturers.
Sure.
And, expecting, quite honestly, that you would want to have that surface prepared the best that it can be and have it as clean as possible so that you would then have your standards. But I think that becomes challenging too, because you have your market forces that will determine.
And we're going to blame it on Jack's group. And it's a marketing problem because they won't let us make it as clean as possible because then they tell us it's not sellable.
Right.
And so they want to make everything be something friendly to a customer.
Right.
So, and I agree. As a ideal world, we would love to have 0 parts per million of any salt contamination at all.
Right.
But if you actually made that.
But I got to sell paint.
Right. Exactly.
Yep.
But I got to sell. No. But so there is a fine balance there. And I think really who ought to be controlling this narrative is the owner. But what we all know when we get into owner meetings, project meetings, that the owner is going to sit back and just listen to the various parties involved. And they may direct it, and some very large companies have corrosion groups that will, determine. Several come to mind for me that I called on, and so I could always depend on them to be very clear on what they expected in a particular job. But that's not the case for probably 50% or more of the end,
higher than that.
The end owners. Yeah.
Yep.
So then it becomes an economics issue.
Yeah.
And how much is that owner willing to pay for the degree of cleanliness that would occur? So it's a fine balance for all parties involved. And, there's, I think you're on the committee that AMP is kind of started and is now restarting again about identifying for particular environments, particular coating systems, what should be kind of a maximum allowable salt content. Interestingly enough, ISO has had a document like that for years.
Yep.
I mean, it goes back to, I think, the early 2000s. And so it's just a hard issue. And
I was going to say, do you guys think the variability is really plays into it? Like with environments, coatings, different cross-link densities, things like that.
So that's exactly where I was going to go. Was I remember one of the most heated meetings that we had a couple of years ago. I don't know, maybe 5 or 6 years ago now. And there was a gentleman in there who was from the desert Midwest and said, "Why do I have to worry about salts? I have no moisture. I can blast my steel and set it out in my yard for weeks and I get no rusting at all. Why do I worry about salts? I can paint over that and never have a problem." And my question back was, does the painted steel that you paint never leave the desert? Because if it leaves the desert, any salt that you had left now is prone to those new environmental conditions.
Yep.
And his answer was, no, it's already got paint on it. We're like, no, that is exactly what the problem is. And because of it being such a global society and your customers are global, you don't know where your stuff is always going to end up. Even if you think you're selling it to somebody here, they may sell it to somebody else. And when you get into that complexity, there really needs to be a standard. And that's really what it keeps coming down to is, and really we're talking about single digit part per million differences and totals.
Right.
So it's not like we're talking about, well, I'm at 1,000 and you're at 900. We're like, no, you're at 8 and I'm at 9.
Right.
Right. Yeah.
And it has to be 5.
Yeah. Exactly.
Yeah. So it really is. It's low numbers. They're difficult to detect. It's small numbers on big pieces of material.
Right.
And just trying to make sure that you get everything. The standard is needed.
Right.
And, I've applauded ISO and cursed ISO for some of the things that it's done, but having that standard, it's a good goalpost.
Right. And I think really, probably if we're honest with ourselves, everybody wants it, but nobody wants to say they want it.
Yep.
And, obviously I do want it. I mean, it makes my company sell more product, but all parties really are benefited by having a standard, a maximum. But it's just that getting there, and it's that changing that mindset. It's throwing away those brooms. It's putting away the air. Let's really clean that surface well. Let's use water. God forbid that you would use water on bare steel, but you can, and there's ways to do it that makes it that work very well.
So Ken, you're in the business of helping rid soluble salts, protect the steel. Let's talk a little bit about how additives can be used to not only remove soluble salts, but to help hold the cleanliness of that blast profile.
Yeah. The ultimate goal of any kind of using an additive, and to be honest with you, it doesn't have to be just with wet abrasive blasting. So I want to back up and make sure that's known, because what we are seeing more and more is the people that are still doing traditional dry abrasive blasting where they can very easily follow up with like a pressure wash and just pressure wash with the water. Typical industrial pressure washer is 2,000 to 3,000 to 4,000 psi. That's perfect. So there is a way to do this no matter what type of surface prep or what type of equipment you're using. But in general terms, an additive will help that water clean the surface better. And what it really does is that it changes the chemical nature of that water. Water typically on its own will want to just bridge over a profile.
Okay.
Meaning it doesn't want to go into the profile. It'll just skim over it. And by putting an additive into the water, you reduce the surface tension of that water. So now all of a sudden water will go into the profile. It's enhanced by the pressure behind that water that forces it even more so to go in there and really flush out that profile. But really in your profile, for most steel surface prep situations, that profile is where your contaminants are going to reside. They're going to be at the bottom of that profile. And the way you know that is if you see flash rust in the very early stages of flash rust, it'll begin to look like a banana that's kind of past its prime, where it's got those brown spots on it. And that's what a surface that is beginning to flash rust will look like. And that tells you that in that profile, in those depths of those profile, there's something in there that's drawing moisture and causing that color change. And
so one thing I want to clarify, if anybody didn't catch it, when you said the surface profile changed the surface tension of the water, what we're talking about is if you drip water, does it bead up or does it spread out?
Exactly.
And when it beads up, that's because the surface tension of the water has more to hold itself together than it does to spread out.
Exactly.
And so either the chemical makeup of the water or the makeup of the substrate, either one of those can affect how tight that water droplet is.
Right.
We use it as a lot of occasions to test different things, like we have some demonstrations with zinc and you can drop water on it and see how it beads up or spreads out.
It's the same thing.
Yeah. It's all the same thing. You can
even
do it on
probably
your
in
walls.
your water-based coatings. Yeah. You even have to deal with that concept too.
I used to do it on walls when I was a sales rep for house paint.
Right. Latex, right?
Yep. Right. Squirt some water on the wall and show them how it beads up or soaks in, and yep.
So I'm sure all along the coating manufacturers have been totally accepting of this additive and its use in all ways possible, right?
Totally.
Totally.
For 35 years.
For 35 years. And coating manufacturers have been late adopters.
Yes. Yep.
of this technology, because we will admit we at first were only good with this type of use for atmospheric systems, and that really we because of all the things we talked about earlier, the less of a chance of water and osmotic blistering, the better chance of the coating performing. But Paul, we did some testing recently that showed some different results, and we're actually kind of changing how we feel about them in general at Carboline. Do you want to give Ken the good news? Pretend like he doesn't already know.
Yeah, I mean, spoiler alert, as soon as this testing was done, we did send Ken a copy, and we sent it to the other salt remover companies as well, and said, hey, we've done some evaluations, because we had worked with all of the suppliers and said, send us in your stuff. Tell us how you think we should use it. How can we use it? How can we misuse it? Right. Let's do some representative immersion testing. Right. And we tested a handful of different linings and a handful of different cleaners at different concentrations and testings and temperatures. And, we even tried a couple of them that we knew the coating would fail, just to see, did this improve that? Mm-hmm. And so we looked at all those results, and we came back and we said, we are totally neutral, and we will allow this to be used. And that was really as a coating company, we had a barrier or a blockade for companies like yours to be able to sell stuff into tank linings. And now we've just kind of removed that and said, hey, go talk to your soluble salt remover people and let them advise you on what you should be doing, and we will permit it if you use it the way they say to use it.
How do you like them apples, Ken?
Sounds good to me. As long as we're at the top of the list. But, if you think about it, and again, I go back to having sold coatings, surface prep, especially for interior, surface prep is king. I mean, that is the utmost as far as the biggest part of any kind of a job, or making sure that a coating system works, is how that surface is prepared. And so having anything on there potentially that's going to impede that adhesion or change the coating system going on there, that is a very logical concern. Yeah. And so, I mean, it's just taken time for manufacturers to grab a hold of that, but then to, as you just stated, to ultimately test. And when you ultimately test, it typically will show, or it always shows. We just ran a 5-year test with NASA, where we had panels that actually were coated with Carboline, that were placed out on the Atlantic beach side at the NASA facility there in Florida for 5 years. And each year those panels were checked. And the genesis, or the reason for the testing, was to understand, is HoldTight, is a additive going to impact a coating system over time? Mm-hmm. You've got to have the time in order to develop a time type test like that. And we just took the opportunity to do so. And what we found is adhesion was not at all made less, but it actually was improved, even after a 5-year period. The other thing that we found that we really appreciated was, in a scribe test, was that adhesion was improved so much that it was failure. We were able to predict through the scribe test that failure, or the life of a coating system, would be extended typically from 10 to 25 to 50%. And that's beneficial for all of us. Yeah. Mm-hmm. I always said as a coating salesman that I didn't mind failures because it gave me another opportunity, but it also opened the door for other manufacturers. Yeah. And so if you can give your customer a good coating system, then it's actually to your benefit, because you'll get the next one that comes up. Maybe not the one that you just did, but you'll get the next one. And,
a couple of the things that you just mentioned there of, from a coatings manufacturer side, we look at things and we say, well, we prevent steel by rusting by putting something on the surface and creating a barrier layer. Mm-hmm. And the idea was always, how are you not creating a barrier layer that now has something there? And it was really just, it's not that we didn't have the people to study it. It was that we didn't study it. Right. And so, like you said, it takes time to put in a test like that. And our testing, we do immersion testing, and it's a year-long test process. Right. And so it's a matter of setting aside those resources and saying, what can I do to test that invisible stuff has been removed by invisible cleaners that leaves an invisible non-residue.
Right.
And so there's a lot of faith that had to go into it. And it really took time to develop that confidence to be able to say, yeah.
Plus, you're using water to administer it.
Right.
That is something we never want to do.
Yeah.
That's the 30 to 40 minute song and dance on soluble salts. There can be a problem, but if you remove them, or as much of them as you possibly can, you lessen your probability for a problem.
Right.
And as we learn more and more about soluble salts, and as our knowledge base grows farther, we're really getting longer life out of our coating systems. As you can tell by listening to this interview, Ken really knows what he's talking about. So if you want to get a hold of him or HoldTight, there's a couple ways you can do that. You can reach out to Paul at technicalservice@carboline.com. He knows how to get a hold of Ken and can get a hold of Ken for you. Or at HoldTight.com is the website for HoldTight, and you can find out more information there. So go ahead and don't hesitate to reach out to either one of them if you'd like to learn more. And so I think what we want to do next is move on to our 4-question segment that Ken is looking forward to.
I've been so excited to have this part.
All right. So, Ken, what's your favorite movie or television show?
I'm a crier. So if a movie draws me to tears, then it's, in my book, a good movie. And the one I've always loved is Remember the Titans.
Okay.
That is such a... it has its Texas roots, so that's actually kind of fun. But it's a great one.
It is a really good one.
Yeah.
What's your hobby? What do you like to do in your free time?
That's a good question. And as we were discussing about being empty nesters, that changes. It used to be the kids, and now it's my wife, and working out and doing all that kind of normal stuff. But what we really have grown to love is traveling. And, this business allows me an opportunity to do a lot of traveling. And so I would say traveling and reading, and when I can put the two together, that's even better. Those plane rides are great for that.
Oh, reading on a beach is a great place to read.
That's even better. With something good to drink.
That's right.
I dream of the day that I can sit on a beach and read a book. As the father of a 7-year-old, I dream. So you said you like to Remember the Titans, so that might give us a clue to this next one. What's your favorite sport or team to watch?
Oh yeah. Well, it would be, and it's funny because, all these websites, you have to have these lists of questions. What's your favorite sport? What's your favorite, subjects in school? My favorite sport is football. I just didn't play football. That's not ever been, what I was cut out for, but I just love it, which then leads to my favorite team, which would be the University of Texas Longhorns. I did get 1 degree from there, so I can say that I am
You're an alumni, huh?
That's right. I am a legitimate as far as my love for them, but I have many generations in my family of Longhorns.
I feel your pain though, because I am a Notre Dame football fan. I didn't get a degree there. I'm one of those. But Notre Dame and Texas both were prominent at one point, and they both struggled.
I have my list of teams. Yes, we have, unfortunately, but we're going to ignore that part. But I have my list of teams that I did not like that would beat the University of Texas, and at the top of that list is Notre Dame.
Yeah. No, I'm used to people hating my football team.
If you were playing that sport and had your walk-up song, your WWE enter the ring, you're up to bat. What is that song? What is your favorite song? What do you like to listen to if you're just driving down the road vegging out?
Yeah. Well, when I'm not listening to podcasts about the University of Texas football team
or the Red Bucket.
Or the Red Bucket. Oh, definitely, yes. Texas would be only after Carboline. That's exactly right. But probably the song that comes to mind is Willie Nelson's Always on My Mind. And I think that's really appropriate as a walk-up song, only from the perspective that you want to always be on your competitor's mind. You want to be resting in their brain.
If you walked up with that song playing, yes, you would be living in there.
Right.
They might be laughing as you're in their brain, but
Giving you a weird look.
Yeah. I think of myself as that other WWE contestant in the ring, and this slow, mellow Willie Nelson song comes on, and I think it would get in my head.
yeah. But it might be like, I can dominate.
No, I think it would be like, I don't know what this guy is going to
You'd be
do.
hearing banjos and
Exactly.
Thank you, Ken, so much for coming on the show and joining
My
us.
pleasure. Thank y'all for having me.
Yeah,
This has
it's been a great visit.
Great fun.
All right, up next is our Tech Tips segment.
You have questions, they have answers. This is Tech Tips.
Hi, I'm Chris Burst, Product Line Manager at Carboline. When soluble salts are a concern, it's good practice to check levels before and after cleaning. But the second check should be before blasting. This reduces the chances of the abrasive blast embedding salts in the profile.
Thank you very much for joining us this week. We'll go ahead and see you guys in another month.